We're going to be talking about derivatives of logarithmic functions. There are two general formulas. First one is the derivative of ln of u is equal to u prime over u. The second one will be the derivative of logarithm with the base of a is equal to u prime over u multiplied by the natural log of a. Let's try these examples. Derivative of ln of x. Based on this formula, x here will be u. Now, derivative of x will be 1 and u here will be x. Derivative of ln of 2x. First, take the derivative of 2x, which is 2, over u here, which is 2x. Cancel these two together. Final answer will be 1 over x. Derivative of natural log of x squared plus 1. X squared plus 1 will be u. So derivative of x squared plus 1 will be 2x over u, which is x squared plus 1. You can cancel one of these x's out. So we'll have 2 over x plus 1. Derivative of square root of x. This will be u. Derivative of x square root of x will be 1/2 of x raised to the power of negative 1/2 over the square root of x. Simplify this further. You will get 1 over 2 square root of x multiplied by another square root of x, because you will bring down x here. So the final answer will be 1 over 2x, as 2 square root of x will cancel each other out. Let's try trigonometric problems on logarithmic formulas. Derivative of sine of x here. The derivative of sine of x will be cosine of x over u here, which is sine of x. The final answer will be cotangent of x based on the trigonometric identities. Now, the derivative of natural logarithm of cosine of x. Firstly, take the derivative of cosine of x, which is negative sine of x over u, which is cosine of x. The final answer here would be negative tangent of x based also on the trigonometric identities. Derivative of tangent of x. The derivative of natural log of tangent of x. Take first the derivative of u, which will be secant squared x over tangent of x. Now, secant squared x here will be 1 over cosine of squared of x over tangent of x will be sine of x over cosine of x. So one of the cosine will cancel out, so the final answer will be 1 over sine x cosine of x. The derivative of secant of x. Take first the derivative of secant of x, which is secant of x tangent of x over secant of x. These two will cancel each other out, so the final answer will be tangent of x. Now, let's take the derivative of natural log of e raised to the power of 2x. Take the derivative of e raised to the power of 2x first, which will be e raised to the power of 2x multiplied by the derivative of 2x here, which is 2 over e raised to the power of 2x. These two will cancel each other out, so your final answer here would be 2. The derivative of ln of e raised to the power of x squared. Firstly, take the derivative of e raised to the power of x squared, which will be e raised to the power of x squared multiplied by the derivative of x squared, which will be 2x, over u here, which will be e raised to the power of x squared, as this will cancel each other out, so your final answer will be 2x. The derivative of ln of 3x. First, take the derivative of u here, which in this case is 3x raised to the power of x, the derivative of 3 raised to the power of x will be 3 raised to the power of x ln of 3 over 3 raised to the power of x. These two will cancel each other out, so your final answer will be natural log of 3. U here will be e raised to the power of sin x. The derivative of natural log of e raised to the power of sin x will be e raised to the power of sin of x multiplied by the natural log of e multiplied by the derivative of sin of x is cosine of x over u here, which will be e raised to the power of sin of x. These two will cancel each other out, and the natural log of e is 1. So what you're left with here now is simply cosine of x. Now, in case you did not memorize the exponential formulas, what I use here is e raised to the power of u is e raised to the power of u multiplied by the derivative of u, which is u prime. As you can see, I copied eu here, which will be this, and u prime is the derivative of what the u here is. So u prime here is 2x, and u prime here is 2 because the u here is 2x. Let's go with this example. The derivative of natural log of x3 plus 2x. Firstly, let x cubed plus 2x here be u. So u prime here would be 3x squared plus 2 over u, which is x cubed plus 2x. This will be the final answer. Derivative of natural log of x multiplied by sine of x. As you can see, this is product rule. The formula for product rule will be uv will be u multiplied by derivative of v plus u prime multiplied by v. So in this case, u here will be x and sine of x will be v. So the derivative of this will be x cosine of x plus u prime here will be 1 and v here will be sine of x over, when that is finished, you can also view this as u according to this formula. So u here will be x sine of x. You can split this apart in order to simplify. X cosine of x over x sine of x plus sine of x over x sine of x. These two will cancel each other out. These two will cancel each other out. So the final answer will be cos over sine will be cotangent of x plus what's left here is only 1 over x. This will be the final answer. There's still x here, which is that. The natural log of tan x plus 1. The derivative of this will be u. Derivative of tan of x will be secant squared of x. Derivative of 1 is 0. No need to put it. Over u, which is tangent of x plus 1. That will be the answer. The derivative of natural log of x squared plus cosine of x. First, take the derivative of the assigned u value, which is 2x plus derivative of cosine of x is negative sine of x over u, which is x squared plus cosine of x. Simplify this will be 2x minus sine of x over x squared plus cosine of x. Simplify this further if you want, but I will just leave it as it is. Now, with this, we will use logarithm with base of a. Earlier, the logarithm is natural log because its base is e. I mean log of e. So that will be converted to ln. But in this case, the natural logarithm here will not be e, but instead any bases including 1, 2, 3, 4, 5, etc. as long as it is not e. So we will use this formula here. Now let's try the next example. Derivative of logarithm of x. If you do not see any number here, it will automatically be 10. So according to this formula, take first the u prime, which is x. The derivative of x is 1 over u, which is x, ln of a, which is 10. Derivative of natural logarithm of 2x with the base of 2. Take first the derivative of 2x, which is 2 over u here will be 2x multiplied by the natural logarithm of a here, which is 2. These two will cancel each other out, so you will get 1 over x ln of 2. The derivative of logarithm of x squared plus 1 with the base of 7 is 2x over x squared plus 1 multiplied by the natural logarithm of 7. The derivative of logarithm of 5x cubed with the base of 3 will be 15x squared over 5x cubed multiplied by the natural logarithm of 3. Let's try using trigonometric functions using logarithmic. Let's try solving trigonometric functions with logarithmic functions. Now, the derivative of log of sine of x with the base of 2 will be, the derivative of sine of x is cosine of x over u here, which is sine of x multiplied by the natural logarithm of 2. This can be the final answer if you want. The derivative of log of cosine of x with the base of 4 is negative sine of x over cosine of x multiplied by the natural logarithm of 4. The derivative of logarithm of tan x, if there is no number, it's still 10 as usual. So the derivative of tangent of x here will be secant squared of x over tangent of x multiplied by the natural logarithm of 10. The derivative of logarithm of secant of x with the base of 3 is secant of x tangent of x over secant of x multiplied by the natural logarithm of 3. These two can cancel each other out, which brings us to tangent of x over ln of 3. Let's solve these problems. The derivative of logarithm of e raised to the power of x with the base of 2 is e raised to the power of x over e raised to the power of x multiplied by the natural logarithm of 2. Just a reminder, the derivative of ex is still e raised to the power of x. The derivative of logarithm of 3 of x with the base of 5 is 3 raised to the power of x ln of 3 over 3 raised to the power of x with the base of natural logarithm of 5. These two will cancel each other out. So you are left with ln of 3 over ln of 5. The derivative of logarithm of x raised to the power 4 with the base of 4 is 4x cubed over x raised to the power 4 multiplied by ln of 4. These two will cancel each other out, so you are left with 4 over x ln of 4. The derivative of logarithm of 2 raised to the power of x minus 1 with the base of 10 is 2 raised to the power of x plus 1 multiplied by ln of 2 multiplied by derivative of x plus 1 is 1 over 2 raised to the power of x plus 1 multiplied by the natural logarithm of 10. These two will cancel each other out, so your final answer would be natural logarithm of 2 over natural logarithm. Let's solve these problems. Derivative of logarithm of x squared plus 2x with the base of 5 will be 2x plus 2 over x squared plus 2x multiplied by the natural logarithm of 5. This will be the final answer. And then derivative of logarithm of x sine of x with the base of 2 will be, this is still product rule. Take the derivative of first, so you will have 1 multiplied by sine of x plus x multiplied by cosine of x over x sine of x multiplied by natural logarithm of 2. Final answer here would be sine of x plus x cosine of x over x sine of x with the natural logarithm of 2. You can split this apart, so you will have sine of x over x sine of x plus x cosine of x over x sine. The final answer here now would be sine of x over x sine of x multiplied by the natural logarithm of 2 plus x cosine of x over x sine of x multiplied by the natural logarithm of 2. These two can cancel each other out. So this will be 1 over x ln 2 plus this one. So this will be the final answer.